Welcome back. In our previous video, we covered an introduction to the Medallion architecture. Now let's understand how it connects to the semantic layer, plus we'll discuss when data becomes truly production ready. As we saw last time, after passing through the three tiers of the Medallion architecture, we arrived at an opinionated or projected view of the data in our gold layer. This gold layer forms the basis of the semantic layer, but the semantic layer adds additional context and meaning to the tables in the gold layer, which enables humans, and more so these days, machines and AI, to understand and engage with data. So this can include human or machine-friendly names, descriptions, and synonyms of objects like tables and columns. It could include assigning more advanced data types over the primitive types that are used in the gold layer. So saying like this number is a percentage or a latitude or a currency, or this string is a city. It could include adding metadata to help you enable effective governance of the gold layer, like data classification tags. And it could mean defining relationships between your objects. Often, the idea of the gold layer is conflated with the semantic layer, but without defining your objects as meaning and relationships, you can't use that data in any meaningful way. The semantic layer usually sits outside of the Lakehouse, and its exact form will be dependent on your use case. A good example of this is Power BI. So when you're creating a report, you import the data from the gold layer, and this forms a path model. But you then update column names and types to make the report more readable and enrich the data. And you use the modeling tab to define the relationships between your tables and objects. And only at this point is your semantic model fully defined. Power BI is a useful example because the semantic model is a built-in concept, but your semantic layer could also be defined using other tools like Microsoft Purview or Databricks Unity Catalog. Whatever your use case, it be it reporting, analytics, or application development, you'll likely need to define a semantic layer in order to describe your data and give it meaning. Each output from the semantic layer is a data product. It's a valuable asset that should be maintained, versioned, and treated as a fully contained product. You may have multiple data products or versions of each, which are consumed by different use cases or used for different types of analytics. So overall, we have data is ingested from on-premise or cloud systems into the raw bronze layer, is then processed to the cleaned and validated silver layer, and projected to the opinionated gold layer. Data is then defined as it moves into the described semantic layer, where it then goes on to serve actionable insights. The bronze, silver, and gold layer usually sit inside of the Lakehouse, but the semantic layer often sits outside. So, now on to our next question. When is data production ready? In software development, we often talk about different environments, and at Engine, we often use a three-tiered approach with development, testing, and production. So in general, the development environment is where engineers are currently working and is therefore the most volatile. New code will be deployed here, and bugs will often be found during this first stage. Things will be changing rapidly, and if the project is actively being worked on, extremely rapidly. Nothing production-focused or client-facing should ever depend on the development environment, as it's purely a place for developers to make changes, trial solutions, and update things. Once developers are happy with the changes made, and hopefully those changes have passed some kind of quality gate, they'll be deployed into the testing environment. Here, the code undergoes more rigorous testing in a more controlled environment. There might be additional tests, including integration tests or non-functional tests, and anything else that doesn't generally fit into a quick feedback loop that isn't necessary during development. Hopefully, at this point, any bugs that have slipped through during the development stage will be found. Finally, once all the tests have passed and all the validation has been carried out, the code will be deployed into production. This is the live code that your wider solution depends on. And if, for example, you're hosting a client-facing web application, this code will drive your public app, and you would therefore hope that it is reliable and bug-free. This is a generalized pattern that is applicable in loads of scenarios, but the number of environments and their purposes can vary. For example, you might require a pre-production environment for additional validation, or a specialized QA environment in order to meet regulatory requirements. How does this apply to our data design pattern? It's slightly confusing that we now have three tiers in both of these separate but related dimensions. In the Medallion architecture, data moves from raw to clean to projected. But alongside this, we still want an environment in which engineers can experiment and change things about the data, including the silver and gold tiers, without this impacting anything public-facing, our development environment. We also want an environment in which changes can be validated, testing, an environment in which we can be as sure as possible that the data is reliable and can be depended upon, production. So, as such, we can design a system as follows. In each of our environments, we have a bronze, silver, and gold tier. It's clear that we don't want any production systems relying on our bronze raw data, as any new data that arrives needs to be cleaned and validated before it can be used. But, as is the case for software development, anything that is end-user facing should be relying on the production environment. The development environment is where engineers are currently working and is therefore volatile. These engineers will need to update things relating to the silver and gold tiers and will need to do so without worrying about affecting these production systems. There could be necessary schema changes, column renames, bug introduced accidentally in calculated columns, tables accidentally deleted, and much more. It is worth noting that though the environment is functionally volatile, the data itself may be more tightly controlled. Data needs to be consistent in order to allow for development and testing. And test data might be created specifically to hit edge cases or fake data used to restrict access to production data. Any changes that are made in the development environment are then validated in the testing environment. And once those quality gates have been passed, they are deployed in production. And within the production environment, nothing should be depending on the data in the bronze tier, as this data is unvalidated and raw. But once we have cleaned and validated the data, both silver and gold tier should be production ready. At this point, the data is cleaned, validated, and not subject to unpredictable change as it is in the development and, to some extent, testing environment. As I mentioned in my last video, it is often stated that data quality improves as you go through the Medallion architecture. However, this statement is flawed. The data in the silver tier is no less production ready than in the gold tier. It is just an unopinionated representation of your data. It might be used to feed machine learning models and data science experiments, and the results of those may well be client-facing. Therefore, data in your silver tier, in the production environment, is very much production data and should be viewed as such. So, to answer our earlier question, when is data production ready? When you're in your production environment, data is production ready when it is in the silver or gold tier. Overall, the opinionation of our data increases as it moves through the Medallion architecture. We start off with data in its completely unaltered, raw form, and we end with data that is first cleaned and then structured for a specific use case. Using the Medallion architecture, we can land and then work with data in any format, whether it is structured, semi-structured, or unstructured. We can impose gates that limit data quality issues. We can support multiple use cases. We can support different workload types, including reporting, machine learning, and data science. We can support creation of tables at any time, and we can support auditing and data versioning. We can also allow for historical playback, as you have each version of the raw data saved. And you can allow for greater agility, where, for example, customer change requests can be dealt with by just updating the gold projection. You can define data lineage and how data moves from source through processing into consumption. And you can allow for flexibility and security, with certain groups being given access to different projections with different levels of sensitivity. An important point is that there's no hard and fast rules for implementing this pattern. Though the Medallion architecture provides us with useful guidance on how to structure our data solutions, there is a lot of nuanced decisions that need to be made. For example, where exactly to draw the lines between the different layers and how much validation is done at each stage, and how much processing is done on the gold storage layer versus how much on the Power BI. And each of these require a balancing of performance, flexibility, data copying and storage costs, data volumes, historical data support, security, regulatory requirements, and loads more. Overall, the combination of this data design pattern and a multi-environment system in which data reliability increases as it is promoted through the environments provides a reliable and flexible architecture that can support many different scenarios. That wraps up our look at the Medallion architecture. We've covered the 3 tiers, the semantic layer, multi-environment deployment, and key advantages of this approach. Thanks for watching. I hope you found this valuable.